Hello everyone, good morning and welcome to today's session. So we discussed about the continuous delivery life cycle yesterday. Okay, so anyone having any questions from yesterday's session, please let me know. Otherwise, we are going to start in next 2 minutes. Okay. All right. So let's start now. So yesterday we saw how the continuous life cycle works. Okay, how what are the different phases, how the application development occurs, and how we can automate all the steps after the initial code has been written and it has been committed to the repository, how we can automate the build process, testing process, deployment, and monitoring. Okay, all of the rest of the process can be automated. So we created a pipeline through which we have automated the entire workflow for the DevOps. Okay. All right. So when we talk about the continuous delivery, so there is a continuous improvement. And whenever we talk about the continuous improvement, there are three most important stages for this. This is your build, where you are actually going to perform the builds. Then there is a testing stage, and then there is a deployment or operate stage. Okay, so every stage is having multiple things associated with it. So whenever we talk about the build, we need to have a branching strategy where we are going to decide which would be our production branch, or whether we are going to take exclusive branch for each and every task and then merge it and close it. Okay, then we are going to decide which of these branch would be a permanent branch, whether we are automatically going to allow build from to be executed from multiple branches, or we are going to have a dedicated branch and then merge everything inside that branch. This will become more clear to you when we go through the source control or a version control or tools like Git. Okay. Next is your source control. Now source control is for your source code control, so that we are covering through Git. Continuous integration, where you are going to merge all your whatever you have written in your code, you are continuously going to merge along with the other users, so that if there is any issue, you came to know it early. Okay. Then there is a data model change. This is an overall development strategy. It's a change over there. Then automated builds are there, you have to create them. And then requirements tracking. So you see there are multiple things to be done inside the build is not just simply one thing, it's a combination of multiple things. Similarly, if we talk about the testing, there is like regression testing, or then there is automated deployment of test environments, release management, test case management, bug tracking. Okay, unit testing, security testing, accessibility testing, and then there is like automated performance test. So you see testing in itself is composed of multiple tasks. And finally, when we come down to the deployment and operations of the application after it has been deployed, then we have to generate the reports, we have to generate the backups, continuous deliveries, their cluster deployments, monitoring tools. Okay, and cloud deployments if you are working in cloud. Okay, and there are real-time reports which have to be generated, patching has to be done on the servers, continuous monitoring of your applications infrastructure, logging, and databases. So all of these becomes a part of the operate. And all of the three platform are under the DevOps. So since you have to manage so many components, so a lot of automation has to be in place in order to manage a bigger environment. Okay, and not only bigger, even in the smaller environments you need to have all of the things implemented. So there is a scope of continuous improvement. Okay, you can start from the build stage, achieve the build. First of all, you can work on builds, then you can improve on tests, then you can improve on the operation side. Then there are a lot many other things from the security perspective that you have to continuously improve. Then you have to include the newer technology. There would be continuous improvement in the tools which you have previously implemented. So you see, it's a path which you gradually achieve, and that's why it's called a maturity. So reaching down to a maturity of continuous deployment and maintaining it so that the all the things are automated in it is required some time to be achieved by an organization. Okay, and it's a sort of complex. It becomes complex when you are including multiple components, multiple environments. So same things has to be done in multiple environments, you see. So as many environments you are having, these things needs to be implemented in all of those environments, like your dev, staging environments, pre-production, production. So all of this has to be built. Okay, so it will be built gradually. So here is the CI and CD process, how it looks like. First of all, it's a closed loop. Okay, the blue one represents continuous integration. The yellow one is your continuous delivery. So you start with the plan stage. Okay, that is where the business is going to sum you up about the requirements of what is required. Then once the requirement stages have been completed and you have all the information of about the feature that has to be developed, then the developers will start coding it. Okay, and then they are going to merge everything in the repository, and the build will be picked from that stage. Okay, now the from here, from the build part, it's the DevOps processes always start. Okay, so you will have to create a build of the initial code that has been written. So these builds would be automated, and once the Jenkins has performed this build, then you will trigger the testing stage. Okay, and you see each and every stage here is a feedback to the another stage. Like for code, plan is the feedback; for build, code is the feedback, and test, build is the feedback, and so on. Okay, so it's a closed loop, and once the testing has been completed, then your release will come. Okay, if the testing and then you will be deploying the code into the like different environments, starting from the lower environments up till production. Okay, and once the deployment has been completed, then the operation stage comes into the picture that we just saw. Okay, so there are multiple tasks like monitoring, patching, and then so there are like reports have to be generated. So continuously you are going to perform this operate stage, and then the monitor stage would be there, and then again plan stage would be there. So this will keep on happening again and again, and you are continuously going to do the continuous improvements in your infrastructure, in your application overall delivery platform, and that's how your overall platform is going to become mature over a period of time. Okay, okay. After the CI/CD comes your continuous development. So what is a continuous development and what are its advantages? See, continuous development is like releasing of the code, whatever you have completed. Okay, as a module, you can directly integrate it and release it. So the advantages of continuous development is your shorter. There are shorter cycles. Due to the shorter cycles, you become more confident because your initial code has already been into the production. So you don't have to worry about the previous code. It's already running in production. You have to continuously write the new code, and larger integrations are avoided due to this because of the shorter cycles. Then because the code is already short, so you don't have to wait for weeks or months before your testing reports or other feedbacks come in. The feedbacks from the end users, from the testing teams, would be quicker because already the shorter life cycle is into work now. Okay, then because there is less amount of code which has been written for the deployment, then there is reduced rework, so you don't have to rework on the code even if something is failing. Then you can easily figure that out and resolve it quickly. As in, for this is for entirely for the developers, not from the DevOps perspective. It's an advantage for the developers of how the work of DevOps can really enhance their productivity. Okay. Yes, Shri, the shorter cycles means sprint cycles, and when you are done with the sprint cycles and reaches to the release state, so those releases would be much more frequently. Okay, it's not one big release which you are doing in 1 year. It's like a shorter releases which you are doing periodically, like in a week or 15 days or 30 days, like that. Okay. Okay, and after this reduces the cause of rework for the developers, and then because the code, okay, that they have written is now already live and working in the production, so that increases the confidence as well, right? Now, when you write thousands or 10,000 lines of code and then you deploy it, no one really knows whether that code is going to work there as expected or not. When, especially when you have combined, like 10 or 15 people have written that entire module, and combining the code and making it run in the production is like no one knows really whether it's going to work as desired. Performance would be up to date. Okay, the latency would be controlled, whether it would scale or not. So there are too many constraints. Okay, so all of those constraints can be managed if you have a shorter span of releases. Okay, and you are continuously updating your code, so that increases the confidence, and it becomes a it also brought in the disciplined development. See, when you have to write, let's say you have to just write around 100 or 200 lines of code or one module at a time, so obviously you are going to write much better as compared to when you have a huge pile of code to be written or huge amount of work to be done. This is comes from the fact that the shorter things can be managed much more efficiently as compared to managing the one big thing. Okay, so there would be disciplined development, and the quality of the development will also improve if you are having a shorter cycles, because you are able to see the feedback and how your code is performing, so you can make the improvements and then go to the next cycle, and so on, right? So this improves the overall discipline development for the developers. So you see, all of the things improves, and it is continuously aligned with the goals of an organization for creating the better applications, which can scale out, which can handle the user expectation. Features are there, and you are continuously improving it. Okay, and that users also knows, because they are also upgrading their application continuously over a period of time, so they are also aware that the value is continuously being added. Okay, and even they can request for the features. This is a very common thing for various applications. They ask for the feedbacks, and that is how they continuously evolve over a period of time, and continuously improves. Okay, and that's what has happened with the WhatsApp as well, right? So they were able to retain such a large user base and still is being used as compared more than any other applications in the same category. Okay. All right, so let's come down to the continuous testing. So if we talk about the testing, so previously, what was happening was that the manual regression testing or manual testing was being performed, which was very expensive for the organizations, because it was kind of a bottleneck in itself. Whenever the code has been written and you were performing the like the testing team was performing the testing, this would takes eventually weeks or even months before the reports for whatever code that has been written and tested. A final report would come into like weeks or months, which would automatically delay the delivery of the application. And then it also has its own issues where the because you will have to if you want to improve this process, then because it's manual, right? So you will have to increase the number of individuals who was performing this testing. Now because you have increase the number of people into the testing team, so what happens is they have to run same test again and again. So that's sort of like boring for the people, so they might skip out on some of the things which should initially have been tested, that might go into the production, and then overall system becomes affected, right? So repeating the things again and again, this is somewhat computers are good at, and humans are good at, like more in doing the newer things, exploring the newer things and implementing those things, right? So that's why the manual testing it has to be replaced with the automated testing, so that because you have repeated build cycles, right? And you are releasing smaller builds, but at the same time, whatever code you have written now, your previous code needs to be checked again, so that the newer code is not affecting the previous code. So you see, although the releases was smaller, still the testing has to be complete, from starting from the initial test up to the later test. So all the tests has to be performed on the system before judging that the application will work as expected in the production, because it's possible that once you write your new code, your previous code stops working. So you have to test it, right? So you again, the previous testing that you have done is no longer effective. So you will again have to test everything, and doing it manually again and again itself was a blocker, and it was very ineffective way, because it took a longer period of time to release the code, so the overall goal was getting defeated. That's why once the automated testing was included for the unit code testing and your functional testing, so it automatically improves the overall testing. Then you can combine, see, still not everything can be automated. Some of the usability with the application would still be tested manually, so that part can remain manual, but it's no longer a blocker. Okay. And you are confident that whatever code you have written, your functionality is working, because your automated functional testing, unit code testing, and these things are already working. And then you also have Selenium to automate it in the browser itself, right, for checking the functionality in the browser, so you can use that. So continuous testing is an integral part, and it's one of the important aspect from the even from the DevOps perspective, that this continuous testing is required to achieve the continuous deployment for any organization. Okay, so this has to be effectively implemented. All right, so next comes your continuous integration. Now, continuous integration comes from the fact that there are multiple developers who are writing the code. Okay, around like 10 to 15 people teams might be there, or there might be even bigger teams than that. Now, because multiple people are writing the code, so they need to continuously combine their code. Okay, so for that, Git is going to help. Okay, now there is like 15 people who have written the code, so they need to merge their code, and after merging they need to like continuously integrate this code and see that this is working in the production, or at least working in the lower environments, and the issues are not there, that the one library is not causing the issue of the other person's code is not working due to that, things like that. Okay, so continuous integration is really required for the any of the projects to work, when the multiple individuals are working in a team, or even the multiple teams are working on the modules. Okay, so if you are not doing it continuously, you are not integrating it, so it's possible that you might see that the sprint which was done earlier and completed, okay, it's causing the issues in the later sprints, when you started deploying everything in the production, and you start with the continuous integration because the code is being deployed now, and you start facing the issues. in the earlier issues, and then when you try to resolve them, the later code stop working, right? So it would become very tense situation, and it would take a lot of efforts to rewrite and rework the entire system. So you need to continuously integrate, so that whatever code has been written can automatically be initially be tested, and this includes that the code which has written would be working and it won't be causing the issue. So continuous integrity helps in increasing the visibility and the greater communication between the teams. They will only move ahead when the initial bugs are fixed, okay? And this allows them to catch the issues early in the stage, okay? They don't have to wait out before this would be reported later. So they can move ahead and they can be confident that the integration is working when they are trying to integrate the code. Debugging becomes less, you spend less time on it, okay? And even if it happens, it happens at the same time that you have written the code, okay? So you are also aware about that and you can fix it, okay? And uh, this increases the overall confidence that whatever the code has been written, it's going to be worked. So continuous integration, if done, it's very cheap, but if not done, then it can really be very expensive for an organization, because then again everything has might have to be reworked, okay? All right, so how does the continuous integration work? Okay, so you can see in this diagram, the developers, let me take the plan. Okay, so these are the two developers uh, who are developing the code on their system, okay? Once the code has been developed, they will check in the code using the git into the remote repository, okay? This remote repository will be basically a remote computer which is used to combine the code, okay? So everyone has to uh, put their code in this remote repository, so that basically it's basically the source of truth. So everyone, whether it's developer 1 or whether it's developer 2, okay, everyone puts their code into the source repository, so whole code becomes available in the source repository, okay? And then this is our CI server or our Jenkins server, okay? So the Jenkins server will adopt the continuous integration process. It will continuously results in the build, okay? And it will take all the code and download all the dependencies, libraries, binaries, whatever is required for your code to be built. And it will then perform the tests and your results would be generated. These results would then be passed to the developers, and they would be able to see if the test cases were passed or not, or whether it resulted in some failures. If something is failing, then they will fix that up, okay? And again push it inside the source repository, and until all the results gets passed, okay? Once all the results are passed, then only they will continue with the development ahead, okay? So make sense? Is it clear to everyone? Anyone having any questions? All right, so let's move ahead. This is how the continuous integration is being done in any organization, okay? All right, so next comes the continuous delivery. Now, we will explain the continuous delivery with the help of a diagram. Okay. Now, what happens is after continuous integrations comes your continuous delivery. Now, whenever we talk about the continuous delivery, the main aspect of continuous delivery is starts after the continuous integration. Till this point, we already know that how the code is working, okay? So this results till this point, okay? This is the continuous integration we are talking about. So till here we already know how it works, okay? After that, the once the results has been like provided to the developers, okay, so the continuous integration part is over. Now we have to start deploying the code, okay? And now this is automated process, okay? Once the results have passed, okay, and then we will first deploy it in the test environment, or this can be your dev environment depending upon what you say. So this can be your test or your dev environment. Then results would again be sent to the developers to view that their code is working in the dev environment. Then automatically this will be promoted to the staging environment. Once the code has been deployed, it then again the results would be sent to the developers that the code is ready in the staging environment as well, and that it has worked. Now, finally, the code has to be deployed in the production environment, but this is a manual step. Now, this is important to understand that what is manual. See, before deploying to the production, you can send out a notification in the Slack channel, okay, that your code is ready to be shipped in the production environment. Now, what is a Slack? Slack is like a basically you can think of it like a messaging platform. Okay. So once you have done the integration with the Slack, there would be a notification published in the Slack that the new code is ready to be deployed in the production and that it is working in the lower environments, like your test environments or testing environments or the staging environments. Okay. And then someone, mostly someone from the app, like overall person who is responsible for the deployments or the managers or someone has to accept that. Okay. So someone will reply with yes, okay, in the channel that it's fine to deploy the code. They have reviewed the report, and then it gets deployed in the production automatically. Okay. So you see that one of the step in this is getting an approval from the team that the code is being shipped in the production and ready for the use of end users. Okay. This part actually makes this continuous delivery. Okay. If we are able to reach the maturity that we don't require this manual part, okay, we are seamlessly moving from staging, or like from all the way from testing to staging to production without any manual entry, then it becomes continuous deployment. Okay. But reaching see, whenever you actually deploy the code, okay, then you have to handle the code effectively, that if something is breaking, then your application would continue to work and your users won't be impacted. Reaching to that kind of automation takes time, okay, and a certain level of maturity from all the DevOps people as well as the developers. Okay. So that's what we call the continuous delivery, and if you remove this manual process, then it becomes continuous deployment. Okay. See, code conflicts and all, this would be tracked when the developers are committing their code in the source repository. Okay. The Sanjay was having a question regarding the conflicts. Conflicts would be resolved here. So whenever you are committing the code, if you are having the conflicts, then tools like Git would be reporting all the conflicts that are resulting in your code. Okay. And then only you will have to resolve it before merging it. Anyways, so all right, any other questions regarding the continuous delivery, or let's move ahead? So Prasad is saying to repeat the CD flow again. So continuous when we talk about the CD, that's continuous delivery right now, or it would be continuous deployment. So if you are able to deploy the code from the lower environment, starting with the dev environment or test environment, okay, up to the staging, okay, and then you have to deploy on the production. But before deploying on the production, you will take an approval. If you have to take an approval for deployment onto the production, okay, then it becomes a continuous delivery. But if it's done automatically, that is from test to staging to production, automatically your code is going to be delivered, then it is called continuous deployment. How we are going to achieve that, we are going to discuss. Okay, we are having the tools for that. But this is what continuous delivery and continuous deployment means. Okay, the most important aspect is to understand that what is the difference between the continuous delivery and continuous deployment. So in continuous delivery, we have to take an approval. So it's a manual process, that deployment of the code would be done with certain manual steps, or you will have to take an approval. Just This is from the fact that you don't want to degrade the user experience. Okay, if something is not working or you require and approvals, then it's a continuous delivery, otherwise it becomes continuous deployment. Okay, so any organization which has to achieve the continuous deployment would at a stage be on continuous delivery initially. So continuous delivery, and later they will be doing the continuous deployment. Okay, and here is the continuous deployment. So you see there is no manual process over here. Okay, so once the users have merged into some branch, their code will automatically get merged, results would be provided, then automatically the code would get deployed into the testing environments, result would be provided to the developers, then it would automatically be deployed into the staging environments, then results would be provided to the developers, and finally it would automatically be deployed to the production as well. Now your development teams understand this process, and they also take certain responsibility of their code. Okay, they have a maturity, right, that whatever they are going to deploy would be live, and they accept, they understand it very clearly. So see guys, for achieving continuous deployment, you have to be properly in sync with your development team. Once they understand whatever mechanisms that you have put into place to handle the issues with the failed builds, or that even if they are writing some code which is not working, how it would be handled, then only you can achieve that form of continuous deployment. So the communication between the DevOps and the developers are really essential part, and mostly you will have to at a level make them aware about all the checks and every testing and all the things which have been put into place to automatically test and make sure that everything, even the failures, can be handled easily. Okay, then only you can achieve the continuous deployment. Sridhar, you have any confusion in the previous slide? Like, if we talk about the previous slide, we were having the manual approval before deploying of the code in the production. Okay, this is continuous delivery, and if we talk about the continuous deployment, it's automated. Yes, Niteshri, the last step, okay, which is your approval. Okay, see, it's not only about the approval. It might be that the production requires some manual steps for the deployment, and this is usually done uh, because you don't want that some engineer out there just triggered and some he was testing something and your production becomes down. So that's why you might cap uh, some of the manual steps into the production. Okay, so that the production doesn't becomes affected, or you put an approval before deploying into the code. Okay, so continuous delivery sorts of, it's a manual thing, right? Someone has to either approve or some of the manual commands needs to be done before the code can be deployed into the production. It's not automated, that's why it's called continuous delivery. Now continuous delivery doesn't mean that the code will be manually deployed. It just means that there would be one of the manual processes, okay, like your approval, or it might be something else that you have kept manual so that it's not automated. But after the approval, automatically your code will be deployed in the production. There won't be any manual intervention over there. Okay, that's why it's called continuous delivery. So people can deliver. Usually what happens is teams wants this flexibility, that usually the developer teams wants this flexibility that they can deploy to production when they want. Okay, so it becomes a manual delivery, right? So it becomes continuous delivery, sorry, that they are willing to deploy anytime they want. Okay, so it's sort of an approval process, right? When they have approval, then they are going to deploy. Okay, it's not like that you are seamlessly deploying everything. But if you are making it sure that once they build and their code is deployed, then it becomes the continuous deployment. That's why I said reaching a continuous deployment is further more complex as reaching to continuous delivery. Okay, in continuous okay. Yes, Sridhar. So approval means testing team or operations team, someone has to flag it. Usually it would be someone from the application team, testing team, someone who has verified that everything is working. They are confident. They have updated the stakeholders that the code is going to be delivered in the production. So that is something I call an approval. Okay, and because of that, since the code is not getting deployed, it becomes continuous delivery. And Sanjay is having a question: in continuous development, what does it in real? I mean, since it's automated, who schedules it? Sanjay, the continuous development is basically a term that you have described to differentiate from the uh, previous development that was being followed, where you are continuously working on the smaller release cycle. Okay, it's like you are continuously upgrading and you are following the sprints and everything to continuously improve the application. It's not like you are doing some one big release or something and you are going to follow all the steps, all the core components that we discussed inside the continuous development. The continuous development is normally followed by the developers. Okay, and this is continuous development is required for continuous integration and continuous deployment to work. Okay, once they are continuously developing the code, then only you are going to continuously integrate and deploy the code. Okay. Okay, so Vishal has a question: what is the preferred way when we there are high number of servers like Amazon example, which gave delivery, like continuous delivery or continuous deployment? So Vishal, I have seen organizations doing both. It depends upon what they feel comfortable with. So usually you will see that application teams are feels it's more comfortable to follow the continuous delivery. Okay, why? Because it gives them the flexibility that they can write their code. Someone can review in last before the release that the code is ready and it's bug free, everything is working fine. They can get in sync with the QA team or someone from the testing team. They are also saying that it's fine to go ahead now. Okay, uh, because there are so many constraints, right? Testing also, writing automated testing also takes time and it's complex. So you need to have a consensus that it's ready now. Okay, so mostly I have seen organizations following the continuous delivery. I have seen very less number of organizations following the continuous deployment, but once they follow the continuous deployment, their developers are aware about it, their devops teams are aware about it, and the process are so much mature that even if if the developers write something which is not working, okay, then it is effectively being handled. Okay, so that's why you will see the continuous delivery is like companies are having more continuous delivery, and it's really tough to achieve the continuous deployment, because even the like changing that kind of environment, making everyone aware about it, handle it gracefully, so it's sort of complex uh, to achieve. Okay, but you will see that after the introduction of Kubernetes and the containers, the continuous deployment is much more easier to now as compared to the previously. Okay, because Kubernetes is having the blue green deployment built in into the system. You don't have to write the new code into it. That system is already having in place. Okay, so if properly done, then you can easily achieve the continuous deployment in the Kubernetes. Okay, and then Nikunj is having a question. In continuous delivery, also approval is manual step or it is also automated? Uh, I believe you are asking for continuous deployment. Okay. Yes. So for the continuous deployment, it's automated. Okay. You are having the automation built like such a thing that it can automatically handle the failures as well. Then your testing is such at such a level that it will automatically identify the issues. You recognize these facts, and then you have built a process which is capable enough of handling all the situations. Okay. You have reached to a level, then you it's automated and it doesn't require any approval. So whatever developers write, if it passes the lower environments, it would be deployed into the production environment. But if something fails in the lower environment, then it's not going to move ahead. Okay, they will have to fix it that and there itself. Let's say testing gets passed, but deploying after in the lower environment like staging environments gets failed due to some reason, then it will never deploy on the production. If something fails initially, it stops. Okay, so Sanjay is saying, how do we confirm production results? So Sanjay, once the code has been deployed into the production, there is a notification being sent to the application team that the code has been deployed into the production environment. Then your monitoring comes into the picture. Okay, you have this different matrices being sent out from your production system into the different monitoring tools are there, which can provide you graphs. Okay, one such monitoring tool is Datadog. Okay, if you have implemented the Datadog agent, then it automatically comes with large number of pre-written scripts which fetches the data continuously into the uh, date time, like there is a time series database where a value for your mattress, let's say your CPU utilization per second, is being recorded and fetch out into the Datadog monitoring tool, or per minute. It depends upon what how you have configured it, and it will plot this graph. Okay, where you can continuously see how your application is performing. I just told you about CPU, then you have memory graphs, then you have HTTP 5xx, 4xx, 2xx, all of these, how many transactions are occurring, things like that, for even for the APIs. And then you can after deploying your code, you can monitor those graphs. Okay, if something is failing or your code is not efficiently written, CPU utilization becomes high, memory utilization becomes high, so you eventually detect the issues with your APIs or your code like that. Okay, so monitoring is the one which provides insight inside the application. Then you have application specific monitoring. There is distributed tracing thing. Okay, if you are having a microservices kind of environment, then there is a distributed tracing like Jagger is there. So if you have implemented that and Neuralink or App Dynamics kind of tools, then you can even monitor the transactions which is happening inside your application. If there is an AppDex score which shows how many transactions are going successfully, if that comes lower, okay, then you will be get alerted that there's something is failing in your application. That is how you monitor the results after deploying in the production. And if everything works seamlessly, then you are aware that the latest deployment that you have done is working perfectly fine. Otherwise, you might have to perform some rollback or things like that. Okay. Okay. So Pratik, we are covering the Nagios. Okay, but we are not covering the Datadog. Datadog is one of the paid tools, and so we are not covering Datadog. There are alternatives to Datadog as well. So there are, like, I will tell you, there as many tools that we are uh, learning. There are so many tools for the monitoring as well, and those each and every tool is doing something different. Okay, so it depends upon organization to organization how they have implemented and what they are using to troubleshoot. The bigger the environment, the more complex the requirement, uh, like in a microservices kind of infrastructure. Okay, where each transaction can interact with multiple microservices, so you have to even track that which where it is failing. Let's say it's interacting with 7 microservices, and lastly your transaction fails, so you don't eventually know, right, which microservice resulted in error. So you have to track that out, and even the more complex situation becomes when the latency is high. So which one is taking the maximum time to process? That's something achieved through the distributed tracing. So that's those are some of the advanced monitoring, but if properly implemented, you can take the advantage of that. Okay. Yeah. So conceptually, I gave you the insights about this monitoring. Okay, how this is being tracked. And then you have logging as well. So if something is failing, it will be captured in the logging, and then all the systems that we are running, it can be, it can have the shipping agents, like your TD agent is there, then Logstash is there. Okay, which can send out the logs to a centralized ELK system like Elasticsearch, which can convert the logs into the JSON format, and then you can plot the graphs in the Kibana, and you can verify the status of your logs if it's resulting in some error or not. If it's resulting in error, then you are aware that something is failing in the application, like that. Okay. So Vishal is having a question: is it possible to have some automated smoke runs written in production environment as well, which can help you to check the sanity of the application post deployment and few test cases with the new stories deployed? So Vishal, usually you associate the health checks. Okay, health checks are written by the application team, and this is one of the requirement through which you identify that your application is healthy. Okay, it might not be checking everything. It's just checking whether your application and all the components related to the application are working fine. Okay, it can check for the DBs, it can check for the caching, it can check for your data stores, that everything is at least working, and you get an okay status. Okay, which confirms that all the components are working fine. Whether the code is working fine or not, that's another thing, but your application is up and running, that's one thing. Okay, and then as I told you, there is app dynamics and New Relic and these kind of things, so you can use them to go into more into detail of your application if you want. Okay, they can even go to the transactional layer. Each and every transaction which is occurring, they can monitor it, they can prepare and score for you of how they are performing. They create a benchmark score and compare it with that. If the previous experience degrades, then they can alert you. Okay. Okay, so Prasad has a question. What would be the operations admin's team role in this flow? So Prasad, as an DevOps person, you would be responsible for configuring the monitoring for your overall systems, applications, and everything. You will have to set the notifications. You will have to make it possible to detect these issues as early as possible in your systems. So you will have to put the automated checks in place that is able to help you identify the issues. Okay, after the deployments. So we are covering the Nagios, so we will understand more about the monitoring from the Nagios perspective. Okay. See, you can put as much monitoring as you want, because there is like huge number of components. Each component can be monitored separately, their results can be monitored separately. So but monitoring is just an indication that something is going wrong. It's up to the testing team to identify if the code is having issue, right? This is something, it's not a proper indication what is going wrong. It should have been detected during the testing phase. Okay, you are identifying that something is wrong with the application, but what's wrong, then again this will have to be troubleshoot down, right? So it's always up to the testing that we consider, because testing can provide you that which module is having the issue, or what's not written properly, okay, or where the application is actually resulting in some logical errors or things like that. User acceptance testing is normally after the staging, Nikunj, if you are asking that, okay, and before production. All right, so here is a diagram for you which shows the difference between the continuous delivery and the continuous deployment. So you will see the only difference between, see, all the stages, everything remains the same between the continuous delivery and continuous deployment. You will have all the test cases, everything written, and your application is going to be deployed to the production. Only thing which is manual is like continuous delivery is having a manual process of deployment to production, while deployment to production is automated in case of continuous deployment. Okay. All right, so here is how the continuous integration solves your problems. So it checks for the symptoms of issues, like if something is having an issue, it will help you out initially. Then you can use it to identify the or spot out the issues earlier. You can create root cause analysis where your code is not getting integrated or getting affected due to the other person's code, or library is missing, like things like that. And then you can easily fix those cause at that period of time, because when you are doing the writing the code, and at that time you are able to identify that that specific code is causing the issue, right? Because the previous code would already have been integrated, so that's not an issue. So your later code is having some issue that you have just committed because it resulted in an error, so it's easier to fix the cause. Okay. So and then risks are lowered in case of continuous integration. So next comes your continuous delivery. So when we talk about the continuous delivery, so you actually check in the code regularly. Okay, so you might checking at least twice or as many times as you want. So you can just once you are confident that something is working, you can check in the code into the continuous delivery, and it will it will create an testing comprehensive testing suite. Okay, and it will provide you the test reports for the same, that whether your code is working or not. And it will also manage your development workspace. So overall, whatever you have written, you will get the results sooner, that everything is working fine or not in case of continuous delivery. Okay. And then here is an architecture showing how the centralized version control system works and how a distributed version control system works. So if we talk about the centralized version control system, it's like it's an SVN. Okay. That's an older version. This was being used previously. And distributed version control system is Git. Okay. We are talking about the Git here. So if we talk about the centralized version control system, see, both of them were having a remote repository. This is same between both of them. Okay, both of them will store the code remotely on another server. Okay, In our case, this would be mostly GitHub or Bitbucket or GitLab, and the these are the uh, you will uh, these are basically the users. Okay, this is user 1, this is user 2, and this is user 3. Okay, similarly here as well. Here the user 1 is here, and user 2 and user 3. Okay, so now let's try and understand what's the difference between the centralized and the distributed version control system. So now you see that user 1 is having the same code. All the three of them had pulled the code from the source repository onto their local laptop. This working copy is basically their local laptop. So now what happens is, once they have written their code and they commit their code, that is, they finalize the code and they are committing, saying that everything is working fine and we want to commit the code, that commit will directly be saved in the repository. That will directly go into the production repository. Okay, this is the repository where all the commits are going to be saved. So whenever a user do a commit, it goes into the centralized repository. So you will see a continuous channel or a continuous network needs to be established between your remote repository and your working repository. So this needs to have a continuous channel working between both of them. Okay, then only you are able to uh, make a use, then only you can able to communicate with the remote repository and issue a commit. Okay, now what's the issue of this? See, there it's having a number of issues. First thing is, you have issued a commit. Okay, this will take a little longer time because it's happening over a network right now. Okay, so that network might be slow, or it will take some time. So you are not sure how, so that's one thing. Another thing is, because it has done over the remote server, it's particularly harder when to revert it back. Another thing is, multiple users are working, so all the commits will be flowing over the network, so your repository is bound to be slow. This was done to avoid the conflicts. But in case of distributed repository, okay, what happens is, there is a local repository. This is like, this is what we call a local repository. We will understand what a local repository is, but that's more when we talk about the Git session. Okay, so each user is going to have a working copy where he is writing his code. At the same time, he is committing inside his local repository. Okay, so you see all the commits that he does on his laptop only. If you see this circle, okay, all the commits are done on his laptop only. Those commits are not right now in the remote repository, unlike the centralized repository. Those are inside in his local repository only here. Okay, he's doing all the commits inside this, and once he has done the commits and everything is finalized, then he can push those commits into the centralized repository over here. Okay, and then other people can pull down those commits. So what is the advantage of this? See, the advantage lies in the fact that this distributed repository doesn't require an active connection to be established between the remote repository and the local repository. Okay, so this is one of the advantage. Okay, so this is particularly faster. Okay, this is fast because it's done locally and doesn't require the remote connection. Now another thing is, if a user 1, okay, wants to share his work with the user 2, they want to share between themselves, they can do it. Okay, without committing anything to the centralized repository. But if here user 1 and user 2 has to share the things, they will he has to first push out the code to centralized repository, then he has to download it here, then he has to push it, and he has to download. They can also do this, okay, but it's since the code is locally on their laptop, and if it's in unfinished state, they both can share directly, okay, without the need of going to the centralized repository. So your centralized repository won't be having the unneeded commits. It will only have the I will take down the question shortly. Okay, so uh, you will see the user one is able to share with the user two, and once the final code is there in the local repository, everyone can push. Once he has pushed the code, then the second user can download the code. All the commits would be available in the repository, and he can work on it. So it's providing much more functionality, that is user can share among themselves, user can share among the remote repository, and everything is local, so they don't require active connection to be maintained with the remote repository. That's why you will see the Git is much better as compared to the SVN and most widely used. Okay, this causes less issues and less conflicts as compared to the SVN. All right, so I'm open to the questions now. So Nupur is having a question. Main repository having the same data. Yeah. So Nupur, the always you will start from the main repository. All the data will always reside inside your remote repository, and everyone is going to clone the data from this repository. Once they are finished with the data, they will commit it back. Now in SVN, commits will always happen into the remote repository directly. Okay, but in Git allows you to review the code and then send it back to the remote repository if you want to. Okay. Yes, Sanjay. It the local repository, it is a cloned copy of the remote repository. So whatever you have in local repository, you have actually pulled down from the remote repository. Okay, it's exactly the same until you have made the changes. Okay. Okay. Vishal is saying how the user one can share with the user two without committing to the centralized repository. Okay. So see, Vishal, both of these users will be working, okay, in the same network, in the same company, okay. They are inside the same network. So they are, if both are using the Linux or Mac based systems, then they can use the Git to directly share. Git allows, see, every repository Git allows it to uh, commit and share between the end users. So both of them can share using the Git. I will show you how it is being done. Okay, but this allows them to share locally between each other without even pushing to the centralized repository if they want to. But this is only required for the certain commits. Normally people share with the by committing to the repository and sending to the remote repository. It's only a case where user one and user two wants to collaborate before sending it, like user one wants to he user two wants to take a pull and then work on it. So it's possible. I will show you how it works in the Git. Okay. And Sridhar is asking, is TFS a centralized version control system? Sridhar, only Git is a distributed version control system. I'm not sure about the TFS, haven't worked on that, but most probably it would be a centralized version control system. Okay. This is having its own advantage, the local repository. Okay. So once you have done all the commits inside the local repository, you can review. See, once you are sending the commits back to the origin, like in this repository, everyone would be downloading it. Okay, so you can intermittently review your code over here in your local repository before pushing over here. Okay, so this is something which allows you to take a one final look what you are pushing into the remote repository. All right, anyone having any confusion between what is a centralized repository, what is a distributed repository? Yes, so Vishal, see, when we are going to learn the Ansible, okay, then you will see that Vishal's question is, can this local repository code be deployed to some environment so that it could be tested? Yes. So Vishal, what happens is, let's say when you are using the Ansible, okay, we will see that you can directly run your Ansible code from your local repository, okay, and make the changes on the production system before merging the code into the production repository. Now, what are the advantages of that? See, the advantage belongs to the fact that you can test your code that it's working. Okay, once you are aware that it's working, then you can finally merge it, or you can create a vagrant machine, run the Ansible over there, and test that it's working over there, okay, and then destroy that machine and then merge your code, because you are aware that there is no syntax error and nothing, and everything is working fine, so you are actually quite sure, so it's possible. Okay. Prasad is having a question, how the code is shared among the users before committing to the repository. So Prasad, normally what happens is all the code is inside the remote repository, everyone downloads from here, okay, and then they make the changes and push back here so that others can download. This is always be your source of truth. Okay, so this will be your truth, the exact code that everyone would be working, okay, and taking a reference. So this is the important part. All right, so let's move ahead. All right, here is a deployment pipeline for you. Okay, so if we talk about a deployment pipeline, uh, it starts with a version control system. So developers would be committing inside the version control system. Okay, they will push all their code inside the version control system. This is your Git basically. Okay, all right, and once the code is there, okay, this will automatically be taken for the build. Uh, from here up till here, okay, Jenkins is going to work. Okay, so once the version control system has been up, then this would be downloaded. This build will be downloaded on the Jenkins machine. Okay, the code will be downloaded onto the Jenkins workspace. Okay, to be more specific, and then the build is going to occur, which will call the remote repository, and everything is going to be downloaded onto the Jenkins, and the build, basically an artifact will be generated onto the Jenkins machine. Now, once the build is triggered, then the unit test cases are going to be executed. Okay, and based on the unit test cases execution, it would be decided if this is passed, then only it will move on to the next stage of deployment. Okay, here, and then the deployment to the lower environments will occur. Okay, like your dev stage and things like that. Okay, like that, and then the auto test cases will be run across these dev environments. It would The code will be tested on the dev environments, and once those passes, then the code will be deployed onto the production. Okay, and once this has been deployed onto the production, then feedback will be provided through monitoring. Okay, there would be effective monitoring, there would be matrices. Okay, and things like that to effectively track the working of the code. Okay, so you are having different types of monitoring, which I already told you. So you can use that as in production feedback, and feedbacks are usually there is also a notification after the code has been deployment. Each time a deployment occur, a notification is being sent to the developer. Okay, that might be an email which is being sent by the Jenkins to the developers that the code has successfully been developed, or if there are some issues for that also, the notification will be sent to the developer. Okay, so you see this is your overall pipeline, how the builds are going to work in any environment. Okay, so anyone having any questions here? This is how your overall deployment pipeline is going to work. All right, so let's move ahead. Sorry, it's like, all right. So the purpose of deployment pipeline, okay, is to gather the issues in an early stage. So it's possible that the issue comes between the version control system and your build. Okay, this might be having some syntax or dependencies error like that, which is resulting in an error. Okay, so instead of detecting this late, you detect this earlier. Okay, so because through CI, so you are going to run a CI which will automatically tell that there is some issue between your version control and your build. So build is resulting in an error, then you can fix it. Okay, this would be sent out to the developer. So he is the person who is going to fix this code and going to recommit everything. Then after he has fixed this issue, it might be possible that the acceptance testing is failing. Okay, there are issues detected with this, so those failures needs to be fixed. Then again these failures would be notified to the developer, and he will have to fix his code. Now once the failures automated testing has passed, so you see over here, then approval will be taken for deployment, and seamlessly it would be deployed onto the production. Okay, so you see it, uh, once you have established this pipeline, okay, the pipeline is allowing you to detect the failures in the multiple stages. So those failures are reported at an early stage. That's why this pipeline is so much important to run the overall builds for the application. Okay, so the purpose of deployment pipeline is clear to everyone. Okay, anyone having any questions over here? All right, so let's move ahead. Okay, so here is a deployment pipeline diagram for you. So you are going to initially commit everything, then there it will going to run in an acceptance test stage, then user acceptance testing will happen, capacity testing will happen. Okay, there can be different environments where the code is being deployed, and finally once everything has working in the lower environment, then you are going to deploy in the production environment, and then a feedback would be received after the deployment, and then again you are going to perform this again and again. Okay. All right, so let's talk about the DevOps tools now. Okay, so there are multiple DevOps tools that we are going to run. Okay, so now there is one such tool like Collectral is there, which can gather all the statistics about your system. So it allows you to gather the information about your CPU utilization, your logs, and things like that. Okay, so you can prepare the matrix, the graphs out of that, and you can also collect the logs and then create the matrix out of that, in the sense which allows them to continuously monitor the status of your system. Okay, so logs are generated everywhere, so it's on your system, your applications are generating log, your network is generating log. So there are multiple logs being generated. Each and every Linux system is generating its own log. Security systems are generating log, firewall is generating log. So you have to club all these logs together, analyze those logs, put some monitors on those logs, that if something is failing, then you should be notified for it. Okay, that what this helps in. Okay, and so you can create all of these matrices in your environment. If you take something like a Netflix type, because see, Netflix is a streaming service. It is having this huge number of microservices running in their environment, so they have around 1.2 million matrices to be monitored. Okay, so they are working on that scale with DevOps, and they are able to monitor these matrices, through which they are able to identify that their 50,000 servers are working fine. If something is getting issue, then those matrices will alert and they will fix them up. Okay, next comes your GitHub. Now, GitHub is the most common repository, the source repository that we saw. So all the developers can push down their code to the GitHub repository. GitHub repository supports both the public repositories. Public repositories are mostly the available to everyone, so anyone can see your code. Why this is being used? If you have heard about the open source software, they require a public collaboration. That is, multiple people around the world are collaborating to develop the applications. This is the most common use of the public repositories. So anyone can review their code and anyone can contribute to the code writing as well. That's the use of the public repositories, but organizations don't want their code to be public. Otherwise people can analyze the code, copy their code, create their own applications, or even they can find the bugs in the application. So you don't want to use the public repository for your organization, so you can create a private repository, in which case only you would be able to see that repository, or the users to whom you have provided the access, and no one else would be able to access the GitHub repository. Now GitHub has comes with a huge number of plugins, and which allows you to extend the functionality of the GitHub. GitHub easily integrates with the Jenkins. Jenkins has the plugins for the GitHub as well. Another thing is GitHub also has the network whitelisting, so that you can whitelist the IP address of the users or your own office network to increase the security. Okay, and then GitHub is having the functionality where you can generate the application integration code. It's a special type of code which allows the application to authenticate the Git using the access keys. Okay, it's different from the password, so you don't have to disclose the password. That's why the GitHub is so commonly used. GitHub, Pratik is having a question. GitHub private repo is paid. Yeah, Pratik. So GitHub was having the private repositories paid earlier, but now it's available for free. Although they have limitations on the private repository on how many people can work on together itself, like on contributing to the private repository. So around two or three or four people can work simultaneously to collaborate, and if you want more number of people to collaborate, then you will have to pay to them. Okay, so that's one thing. If you don't want to use GitHub, then you can use the Bitbucket as well. Bitbucket is an Atlassian product. Okay, so it allows you to create the private repository. See, previously what was happening was GitHub allows to create the public repositories for free. Private was paid, but now both are there. And Atlassian used to have private repositories for free, public repositories were paid. So but now both of them has allowed to create any type of repository that you want, and they won't be charging for that. Okay, but they are having a limited set of storage, and there are restrictions on how many users can collaborate, things like that. So if you are having a paid account, obviously the organizations are having the paid account. But if you want to host your own repository, see, some organization like financial organizations are not fine with keeping their code externally on GitHub or Bitbucket, so they can keep their code on their own servers. You can install the repositories also. So you can install something like GitLab. Okay, that allows you to keep the code on your own server. It has all the functionality similar to the GitHub or Bitbucket, and then you can manage your own code. Okay, that's also possible. All right, next comes your Jenkins. Jenkins is our continuous integration and continuous development tool that we are going to run. Jenkins allows us to perform the builds. It also allows us to perform the deployments. Jenkins comes with numerous number of plugins with itself. So initially you will see Jenkins doesn't, when you install the base Jenkins, it's not having that much functionality. But it is comes with the large number of plugins. When you install those plugins, okay, the functionality of the Jenkins increases. It's possible to run the Jenkins into the multiple ways. Those plugins gets continuously upgraded. Jenkins itself gets continuously upgraded. More and more plugins are being created. Then if you are not able to find some plugin, you can create your own plugin. If you want to write in some language code manually, then you can go ahead and write it. Okay, if you want to change the Jenkins UI, you can use the Groovy. It's written in Groovy, and you can use the Groovy syntax to change the UI or add additional functionality. So it's entirely, you can make Jenkins work as you like. Everything is configurable, so you can get any functionality out of Jenkins whatsoever is required. Okay, so Prasad is having a question: can AWS S3 bucket be used as a repository, although cloud is not covered in the training? Asking if it is possible. uh, Prasad, the main thing is, for the repositories to work is the versioning. Okay, S3 also provides you the versioning, so it's possible to use S3 as an repository. Okay, but I won't suggest it, although it can be used. But the functionalities like reviewing the code, okay, creating the branches, things like that is not available in the S3. Okay, so although you can use it if you want, because it allows the versions of the files to be created automatically, so that thing would be done. But you see, an important aspect is of branching that is not supported in S3. Another thing is, you can't review the code. When you push the code, you can't review it before merging, you can't comment it, and things like that. Okay, so although you might be able to use limited, but it's certainly not a good way when you have lot more developed products around the repositories to use the S3. Okay, now next comes your Docker. Docker is basically your containerization tool. Okay, now when we talk about the Docker allows you to package everything inside the containers, so that you don't have to run the builds and like that. You perform the build. Uh, Developers can perform the build inside the Docker container, and then you can create an image of that container and directly deploy the containers. It's like you are deploying the entire container on in your environment. So you are going to use Kubernetes or Docker Swarm to deploy your containers. Okay, in that's a bigger ecosystem in which you deploy that supports the containerization. So once you deploy them, your application will come up in a matter of few seconds. See, when we are running the build and deployment, it can take hours before our builds gets completed and gets deployed. But if we are running the containers, that's much more fast. Okay, you don't have to run the builds again. Okay, it's only done one time and an image is created, and every time a deployment has to be done, it will automatically deploy the container. In case of build, you create a build artifact like your war file, and then you can keep on deploying those war file or tar file depending upon what you have generated. Okay, another thing is the Docker allows you to bring the application newer containers up in matter of like 5 seconds, while deploying the artifacts through Jenkins can take hours before it gets completed. Okay. Uh, Pratik is having a question how Docker benefits over Jenkins. Pratik, Docker doesn't benefits over Jenkins. Docker is an application package. Okay, how you package your application. So you will still use the Jenkins to deploy the Docker containers. Any of the deployment function, you are still deploying the Docker containers, right? So Jenkins will be taking care of the deployment of the Docker containers, how the deployment will work. We will still use the Jenkins for it. Okay. All right. Next comes your Ansible. So Ansible is a configuration management tool, and we are also covering it similar to that of Puppet, Chef, and Salt. Okay. All of them performs the same function. Ansible, Puppet, Chef, and Salt. Now Ansible allows you to implement any of the tasks that you are doing manually on the server. You can automate inside the Ansible. Ansible is having its own modules. It allows you to configure anything. Then when the system, a new system comes up, it can automatically create the system in exactly the same condition from the scratch in a matter of few minutes. So let's say we created a web server, okay, and we are running like 1,000 websites on that web server. So we are having all these virtual hosts running inside our Apache web server or Nginx web server, and we have to configure those 1,000 web applications. So now if you create a new server, or let's say we create 15 or 15 new servers like that, okay, to scale our application or scale our web server. So it will take a considerable amount of time. It will take few days or like number of hours before we can build that up. Okay, and if changes are required, that would be much more complex. Like making a change on 50 servers should be consistent. Okay, if you give 50 servers to different people, they are going to work differently. Okay, and we want them exactly alike. So how do you achieve this? This can be achieved through Ansible. You can write everything inside the Ansible, and when the Ansible runs, it will make sure that each of the steps are being performed in exactly the same way on the servers. It's like a blueprint. Okay, whatever has what how you are building your servers, everything would be inside the Ansible. And once the Ansible run, it can create the servers from scratch up to that position for you. Okay, all the four tools can do it for you. Another thing is all of the configuration management tools. Okay, you can use the Ansible for the build and deployment as well. So what you can do is you can write all the steps of build and deployment inside your inside in the Ansible, and then trigger the Ansible builds through the Jenkins. So you can do an integration between the build and release tools and your configuration management tools, and then trigger them so that every time a build and release is being done, then it will trigger the Ansible, and Ansible will run the builds for you and do the deployments for you. That is one of the way. Now there are certain advantages which allows the configuration management to perform. If you want to change some of the steps for some of the applications, because there will be number of applications, you might have some of the steps different in each application. So configuration management tool can handle that for you. Okay. And because it always runs in exactly the same way, so you can even provide the builds to your developers without worrying that they can break the system. Okay. uh, so Sridhar is asking, are these free tools? Yes, Sridhar, these are free to use. They are all are open source. So Rishi is asking for example. So Rishi, I already gave you the example, like how they can perform. See, if you are having, let's say, 10 binaries to be installed on the system. Let's say you, whenever you are building up a system, there are number of tools are required, like htop, or you want to have ntp running on all the systems and things like that. So you can put everything inside the Ansible. You can put the steps how the you are going to install the nginx, or how you are going to install the uh, Apache web server inside the Ansible. And then you can put on the configurations, like all the vhost configuration that you want to create, that will be running your website, setting up the doc root server name, those kind of things. And then when the Ansible runs, it will perform all these tasks automatically on the server for you. Okay. And it will also show you what are the results. It is idempotent. That is, if you have run the task one, then you can keep on running it again and again, and it will not do anything. It determines the state. We are going to discuss about this more when we do the configuration management, but this is how you can automate everything through Ansible or Puppet or Chef or Salt. Okay. And perform the builds and releases as well. Okay. So Ansible, the configuration management tools are very much powerful, and this is how you actually manage the large number of servers. Okay, so if you are having like 1,000, 10,000 servers, uh, Ansible or Puppet or Chef, they can execute in parallel. So see, right now, if you write a shell script and execute it, it's a serialized tool. Okay, so it will execute serial in a serialized way. It will execute on first server, then it will execute on second server. This is very slow if considering we are having thousands of build to run, okay, on thousands of server. And copying a build, let's say, take 20 seconds. Okay, so multiply 20 seconds into 1,000, that comes out to be 20,000 seconds. So just think like how much time it's taking to just run the build only. Okay, then there are other steps, and doing an SSH will itself take time. So you will never be able to manage something in a serialized way if you are working on that scale. For that, you need to have these configuration management tool, and they can uh, just run in parallel. So if you execute on thousands of server in parallel, then it only take 20 seconds to copy the artifact. So you see how powerful they are and how easy it becomes. And you can integrate Ansible with the Git. Okay, this is what we are going to do. So we are going to, whatever code we are going to write in Puppet, Chef, Ansible, or Salt. Okay, these are the four tools. So we are going to integrate them with the Git. Then everything becomes repeatable. So if you make some change to the Ansible configuration and something goes down, then you can easily revert back to the previous version. Okay, and then the configuration will work. Okay, like that. So you can easily create the servers from scratch. If someone comes to you and tells you that create 10 servers right now, we require that, or some load is coming or things like that, you can create it. If someone asks you to create a replica of your production in some other region, then you create in matter of few minutes, like that. Okay. Okay, so Bala has a question. Is Ansible similar to Maven? No, Bala. The Ansible is not similar to Maven. Maven is limited to Java based projects. Okay, and it helps in managing the dependencies for those projects. That's the main purpose of Maven. But if you see Ansible can work on almost any kind of uh, languages out there. It can handle any of the builds and deployments. You can write anything inside the Ansible. You can automate it any of the way. You can deploy WebLogic, paid softwares. You can make it run anywhere. Okay. Pratik is saying means it can be integrated to Jenkins and Docker. Yes, Pratik, you can integrate. See, wherever you are doing something manual, wherever if you are even running one of the single command manually on the Linux system, you can automate that through Ansible or any of the configuration management tool that we are discussing. I will show you. I will even show you how the Ansible can execute. So we are going to create 3 machines and then use the Ansible to execute the command on everyone like that. Okay. And Salt is also very much powerful. It was created for this purpose only. Okay. It is also very powerful and it's very advanced because it can come after all of these configuration management tools. So if there is some of the minor issues, they all everything was being fixed inside the Salt. Okay, so Pratik is having a question. Also to GitHub and all these can be controlled through Ansible. So Pratik, Ansible does comes with the Git modules as well. You can use them for automating certain aspect of the Git as well. Okay, but GitHub is something different. You are committing the code. Okay, so uh, those kind of requirements normally you don't automate through Ansible because you are creating, that's a custom requirement, right? You are writing a code and you are committing something. That's not a repeated process. Files, names, everything will change, but there are certain aspects through Ansible, the modules which are there, so you can automate that through the Ansible. I will show you how you can automate that. It will become more clear to you. Okay. Okay, Vishal is saying, considering big organizations, do we have to install Ansible on a standalone server or some desktop or laptop machine? Yeah, so Vishal, you create, see, Ansible can run from anywhere. It can run from your own laptop or it can run from any of the servers in your environment. It doesn't require any uh, previous things like any agent or something running. It works on SSH directly. Okay. Now, but the if you see normal architecture of how Ansible is running, so there is a workstation node basically created. There is a one dedicated node being created for the Ansible. You install the Git and Ansible on that node and then manage the configurations using the Ansible on all the other nodes. So you make all the other nodes in your environment accessible to that one node where the Ansible is running, and then Ansible can control all those nodes for you, so you don't even have to log in to those nodes anytime. You can just log in on the Ansible. See, even if you are having 1,000 server, you don't have to log in on any of the server. You have to log in on Ansible server, and through Ansible you can run on any of the servers like that. Not only run, execute the commands, create those servers, identify the issues, configure the centralized logging, automatically building up the servers. Okay, everything is being supported by the Ansible. Okay, so Sanjay is having a question. Can we use Docker Ansible without the plugins like Jenkins? See, Sanjay, the Jenkins is your CI/CD server. That's exclusively for the build and release. Okay, so you can't replace the work of Jenkins. Okay, from Docker or the other tools like that. Jenkins is having a unique position. It's performing the builds and releases. When we discuss the Jenkins, it will become more clear to you. Okay. uh, so each of the tool is having his own things, so you can't replace one thing with the other like that. Okay. All right, then comes the Nagios. So Nagios is our monitoring tool. Okay, it allows you to deploy the agents, that is NRP, to be more specific for the Nagios. And NRP agents can run on any of the system. You are going to install a Nagios server, and then those agents will run on any of all the nodes out there in all the servers in your environment. Those agents are going to communicate with the Nagios server and going to update about the state of the application or the server. So let's say if CPU utilization increases, that agent will send that information to the Nagios server, where a logic will be implemented that if CPU utilization goes above 70, then give an alert. Okay, like that. Or if memory is there, or if some process is not running, as website is not running, website error code is coming, things like that. So it can monitor all those things for you and send out the alerts for to you. Another thing is you can configure the groups. So you can if there are number of users, let's say 12 users, so you don't have to put in the 12 users email id each and every time across each alert. What you can do is you can create a group and then send an alert to that group, or make all those users a part of that group, and all of those users will receive the notification now. Another thing is the Nagios allows you to and Nagios comes with a UI, user interface, where you can easily search for any node in your environment. All the alerts that have been configured would be shown to you over in the user interface. Another thing is you can generate the reports inside the Nagios, and then you can have a detail like how much time the node was available, or it was down, or was not responding, was having issues like that. And then you can work towards improving the availability of the resources in your environment. Okay, so that's also supported. So we are going to learn the Nagios. That is our infrastructure monitoring tool. Okay. Remember, there are different types of monitoring tool. Nagios is an infrastructure monitoring tool. Next comes your monits. Okay. So now what monit does is monit can look out for a process, specific process. Okay. So let's say we configure monitor to look out after our web server, that is our Apache or Nginx. So we can configure the monit to look into this process, and if somehow that process stops due to some issue, or might be, the process can stop because of any of the reason. Okay, then monit will try to restart that automatically at that point in time itself. Okay, so it's basically like a watcher which is continuously watching a process. If it's running, it's fine. If it stops, it will continuously trying to start the process. Okay, until it comes up, and at that time it can also send out a notification to you. So the logic behind this is, if you try to start the process, it might be down arbitrarily, so it can reduce the downtime. See, if Nginx goes down, your application is down. Now if monit tries to, and you might be unavailable at that time, you might be away from your system, it might be the night time and you are not close to your system, then your application is down, right? So at least monit can try to start that. If it's able to bring that service or process up again, so your site or your application would start working again, right? So you want this, and you also want a notification like an email delivered to your inbox, stating that the process failed at this time, and then monit restarted at this time, so you are aware that something did get failed and monit was able to start that. Okay, so Pratik is asking, how is monit different from Nagios or Ansible? So Ansible is there for configuration management. Okay, the Ansible will configure the Nagios and monit. See, you can install Nagios and monit from the Ansible. If you know how to work with Nagios and monit, then you can automate it. So any of the node that you want to install Nagios agent, you can automate from the Ansible. That's the work of the Ansible. Ansible is not monitoring anything for you. It's only automating the installation or the configuration for you. So whenever a new node comes, automatically the agents are there to monitor everything. So whatever we are going to write in Nagios, you can automate that through the Ansible or any of the configuration management tool. So Ansible is completely out of picture of monitoring. Okay, it's automating the installation process or configuration management. Now, coming down to Nagios, Nagios is actually monitoring the application. It's just monitoring. If something fails, it will alert you. Say if it Nginx stops, it will alert you saying that Nginx stops. Nginx has stopped on this node. So it's your responsibility now to look into this matter and get it resolved. It's not going to try to restart it, although there is a way to do it, but normally the it's just doing the monitoring. Okay, and then comes your watch process like Monet, who is not concerned about the CPU and all or memory. He is not concerned about those kind of monitorings. He is only watching the process, some specific process, and will try to start it if it gets stopped. That's what the use of the Monet is. Okay. So Onkar is saying, can we say that Jenkins, GitHub, and Ansible is used by developers? Nagios Monet Logs is used by operations support team? No, Onkar. There, as I said to you, there is no there is no separate developer or ops team. Okay, whenever we talk about the DevOps, it's a complete thing. So it's both, you are combining both of the efforts. Okay, so all of these things which you mentioned, this will be under the scope of DevOps. Okay, developers don't have that much of knowledge about these things, and they are not even concerned about that. Their main uh, goal is to convert the business requirement into the code. Okay, that can be implemented in the application, and that's all they are worried about. They are not responsible for build and releases. They are not responsible for servers. They are not responsible for deploying of their code. They will only help you understand if something is from the issue is coming from the code end. Rest, how you are going to run that code, how you are going to monitor that code, how you are going to build the code, deploy the code, anything, everything comes to the DevOps. Okay. Okay, next comes your logs.io. So logs.io is basically a tool which helps you to automatically collect the logs from the different systems out there. Then you can use the logs.io to analyze the logs. The logs would be converted into a JSON format, like a key value pair. Okay, and the uh, each and every log you can search directly into the logs.io. It's simply an ELK. Okay, but so it's provided as a software as a service. That is, someone else is managing the ELK for you. You are just sending all your logs inside the logs.io and monitor how the logs is performing, like that. Okay, that's what logs.io is. It's a paid service. It's not open source or free. Okay, next comes Consul. So uh, everyone knows about the DNS, right? Or what is DNS? Can anyone tell me what is DNS, how it works? Anyone want to give it a try? What is DNS and how does it works? So Bala says it's a domain name service. Yes, domain name system. Yeah, that's fine. What is the main purpose of DNS? Name resolution, right? Uh, Absolutely right. So it resolves the name to the IPs, okay, or vice versa. That is what we call reverse DNS. Okay, so it can resolve. See, remembering the IP address is a complex task. You can't remember all these IPs. So what you do instead is you assign them a name, and DNS is going to resolve the name to IP. Okay, that is the primary work of the DNS. Now, we I believe everyone is able to understand the dynamic infrastructure at least to some level now. So just think that I told you that the auto scaling or the containers, okay, these are the two primary things. They can increase the number of servers, okay, automatically in the behind when the load is high, depending upon the CPU metrics. Let's say it crosses the 70 threshold, so load is high on our servers right now. So what happens is this service can automatically monitor this load, okay, and it will bring new servers behind the load balancer. Okay, so now there are new servers, and Ansible can run on those servers automatically and can configure those servers to our production servers. Now it's production ready, right? But how do you know, okay, or how do you handle the DNS for those domains? Okay, so which servers are running behind the load balancer? How do you know that? Okay, or and how do you automatically create the DNS and route the request to your servers? So that is something Consul can do. Consul is an automatic DNS enabler. It works as a service discovery. So what is service discovery? It automatically identifies the service and the servers required for those service. So if you are automatically creating the servers, you don't know the IP address, right? It's coming and going, it's continuously changing, right? So you can't work on a traditional DNS where you know the name and the IP and you create a DNS record. So that's not possible now. Okay, so what Consul does is it detects the server and it can automatically create the DNS records. So whenever you query a service, it can provide you the servers which are right now active behind the load balancer. Okay, so that's what we call uh, Consul as an service discovery. Okay, and once you have configured the Consul, you know where to run the Ansible and how to configure it, like that. So Ansible also needs the IP address and the names, right, to run. So all that information can be provided by the Consul. Okay, and Consul helps in the service discovery, which is an essential part. Similarly, with the containers, you will see the containers can come up and go down very quickly. So you will never know the IP address, and it doesn't really we don't need it when we have such kind of tools for the service discovery, which can automatically identify, list the IPs, which helps our tools to connect to the servers, run the configuration, and then destroy them when not needed. Okay, so that kind of complexity can be handled by the Consul for us. Okay, anyone having I hope everyone able to understand what Consul does. Okay, and yes, Pratik, it can do the aliasing. That's basically it can create the records which are resolving new servers which are being created. It can identify on the basis of tags and automatically create the records, route the services, request to them, and when destroyed, it can remove them. Okay, so always it's the source of truth. Whenever you want to identify what is the servers running behind, call the Consul. It will provide you all those information and automatically keep the updated information with itself. All right. So if we talk about the DevOps toolset, okay, Yes, console is having the UI as well, but normally, see, always remember that UI is something, a secondary thing for the DevOps. Why? Although it might appear to you that UI has its benefit, the problem is that you can't automate the things inside the UI. Okay, it's possible that you have to go there and click on something and the things start working, but at least you have to log in and click on something, right? That's not the automation. Okay, and whenever we talk about the DevOps, we only talk about mostly talk about the automation, right? So that's why you will see that the even though the tools provide the UI, like Puppet is also providing the UI, okay, Chef is providing UI, Ansible has Ansible Tower, and so on. So each of them is having the UI, but as in DevOps, no, I didn't see any of the teams or most of the teams, anyone is relying on the UI part. Everyone works on the command line, okay, because that can be scripted, that can be automated, that you can automate. A lot of tools are there to automate those stuff. Okay, so okay, now Nikhil is having a question. Are we covering the Puppet and Chef? Yes, we are covering the Puppet and Chef. Okay. All right, so let's talk about the cloud computing platform. There are multiple cloud computing platforms available, like Amazon Web Services is there. That's a public cloud provider. Then Pivotal is there from Cloud Foundry. Okay. Then Google Cloud is there, so you can use that as well. That's also a public cloud. Microsoft Azure. So major cloud providers like Amazon Web Services, Microsoft Azure, and Google cloud platform. These are the three of the main providers. Okay, and then there is Rackspace and OpenStack. OpenStack is the only private cloud provider out there. So you can take the OpenStack software, implement in your own data center, and create your private cloud. Okay, that's also possible. Okay, so Prasad is asking, we are covering Terraform. No, Prasad, we are not covering the Terraform. Okay. Rushi, we are not covering the cloud computing platforms. All of them are very big and they will require a separate training. Okay. DevOps is not dependent upon any of the cloud computing platform. You can create or and run DevOps, like you can work with the DevOps mindset in any of these cloud computing platform. It will run anywhere. You can even run in your own data center, your physical machines also, right? So DevOps is not aligned with the cloud computing platforms like that. Okay, that's entirely something different. But obviously certain aspects of the DevOps can be fueled by the cloud computing platform with the ease with which it allows the automation to be written. Okay, so you can call their APIs and create the servers on the fly and then run the DevOps tools on them. So that's something which really integrates, but overall DevOps is separate, right? It's you can implement it anywhere. Then comes your virtualization platform. So if we talk about the virtualization platform for creating the virtual machines, there is VMware, KVM, Zen, VirtualBox, Vagrant, and QEMU. So you can use any one of those virtualization platforms, and it will allow you to create the virtual machines over your physical servers. Okay, and there also you can run the DevOps practices. It's completely isolated. So from that, okay. Then comes your Linux operating system installation. Okay, now if you are working on a physical server without a virtualization, then you will have to install the Linux operating system on that. Okay, you can't directly run the image there. So you are having if you want to automatically install the Linux operating system, then you can use Kickstart, Cobbler, or FAI. These are the tools which are available for you to install the Linux operating system. Right now you will not see that this is mostly done. Why? because there are images already created for the operating system. No one, I haven't seen like in any of the cloud provider or anywhere, like back uh, 7 to 8 years back, I used to work on installing the Linux operating system. After that, I haven't like worked on now for installing the Linux operating system. It's completely become obsolete. Usually the images are provided to you, so you directly use those images to create the server. It saves a lot of time. Okay, but if you want, you can use any one of those and it will automatically help you in the Linux operating system installation. Then comes your configuration management tools, which we were talking about. So there is Puppet, Chef, Ansible, HashiCorp is having a Terraform, okay, and then there is AWS CloudFormation. They, all these tools allows you to turn your infrastructure into code practices. So we are covering Puppet, Chef, Ansible. So these are the major tools. Why we are not covering Terraform or CloudFormation? Because they are specifically related to the cloud related technologies. If you see Terraform or CloudFormation, they can help you automate the cloud computing resources. So once you become familiar with the Amazon AWS cloud, you can write that as in code using Terraform or AWS CloudFormation. And this is something out of like this is not exactly the DevOps, although it also comes under the DevOps. If you want to manage the cloud, you can manage it. Okay, but this is we are specifically limiting to the very core DevOps practices where this is not a part of it. Okay. Okay, next comes your test and build systems. So if we want to run the CI/CD kind of stuff, so there is Solano Labs is there, Jenkins is there, Gradle is there. So we are covering the Jenkins and we are also covering the Maven. Okay. Then there is a monitoring and alerting tools. So monitoring and alerting, now this is a very big thing. Okay, and there are lot many tools in it. Okay, and you can it's a very big field inside, because you can monitor each and everything. So there is New Relic. Now what New Relic does is uh, it can monitor the applications for you. Okay, it has also introduced the distributed tracing now. So it can you can monitor your different microservices, how the request is actually flowing through that microservices components. You can monitor that as well through New Relic. Then New Relic also allows you to test the applications. Okay, like after logging into the browser, some element is present or not, like that. So it can log in inside your application and then test there some element is there or not. Okay, a critical element which might not be in your application, so you should be alerted. That's also possible with New Relic. Then New Relic has agents to run on your system and monitor the system resources as well and alert you for that. That's also possible, and it's a paid tool. Okay, so you specifically get built for New Relic, but it's also most commonly used by organizations to monitor the application. Next comes your PagerDuty. Now PagerDuty is PagerDuty and VictorOps. These two work in a similar way. Okay, VictorOps is by Splunk. Okay, it was previously a separate company, but it was purchased by the Splunk, and PagerDuty is another tool. So what it does is PagerDuty has the functionality where if you get an alert, it can automatically call you on your mobile. Okay, that there is an alert, and then you will have to acknowledge on your mobile that you are looking into it or something like that, so that everyone knows that you are aware about the alert. So what PagerDuty and VictorOps can do, it can send out a call to you, it can send out an email to you, it can send out an SMS to you. Okay, so they will alert you regarding the issues in your production environment. Okay, this is what their work is. Okay, Pratik is having question. Are we going to cover any monitoring, alerting, and trending tools? So Pratik, we are going to cover the NECUs. Okay, that's our monitoring tool that we are covering for the infrastructure monitoring. Next comes your Sensu. Sensu is a tool which allows you to gather the error logs from anywhere that is happening and send out an alert to you. So you can monitor the logs from the Sensu. Okay, and if some error is coming in your application logs, then it will automatically send out the logs to your email id. So you can integrate Sensu with all your applications, and then if something fails, Sensu will alert you. Then there is X Matters and Blue Medora. Okay, and then there are comparatively more, some of the more monitoring tools which not have even been mentioned here. Okay. Okay, next comes your containerization. So when we talk about the containerization, we are basically talking about the packaging of our application, how we are going to ship our application. For that, we have Docker that we are covering. Okay, then we have Rocket and LXC containers as well. Okay, but the most famous one is Docker that we are covering, and because it's from the application end, and you will see Docker is leading by far the containerization. All the development that mostly the development has been done with the Docker itself. Okay, then comes your process supervisors. Okay, if we talk about the process supervisors, there are different process supervisors like your monet which we are covering. Then similar to the monet, there is R unit, there is supervisor, there is god, Lupil, upstart, systemd. Systemd is in the Linux like RHEL 7 built in or Ubuntu latest version. So they it has been built inside the Linux only. It's a system wide utility. So you can, if you don't want to use Monet, it comes with the Linux itself. So you can use the systemd there. Okay. Next comes your security. So if security is an important part of the DevOps because all the system wide changes are done by the DevOps persons. Okay, so they are creating these instances, managing the cloud, they are managing the instances, deploying the code, creating the configuration. So they are basically doing most of the stuff, right? So the security also belongs to them only. So you can scan the for the various bugs or various security flaws in your systems using any of these tools. There's Norvi Threat Stack, there's not Veracode, Scurine, Sonatype, Evident.io. Okay, so you can use any of these security tools and scan your system for the issues and then fix those security loopholes. Okay, in your system. So that's from the security end. Then comes an orchestration. Now, when we talk about the containerization, okay, so container requires a networking to be set up. By default, the networking is not that much strong. Then you have to deploy the containers. So if you have to deploy the containers amongst large number of nodes, then you will also have to take care how the communication happens on those containers, how the IP addresses are assigned, how the request is being routed, how the rate limiting is being happening. Okay, and whether if something is failing, how you are going to ship the logs, how you are going to start the containers. If some container is going down, then you will have to start the backup, start back that container. So there are like numerous things required for running a production level environment in the containers. Okay, for that you need an orchestration tool which helps you with the manage automated management and scaling, discovery. All of this part needs to be done inside the container. Now discovery is really important in the containers because containers can come up and go down really in a very short period of time. It just takes 5 seconds to bring a container up and even smaller time to bring the container down. So you need to continuously monitor that and have a discovery in place, then scale out the containers, load balance the containers, do the deployments on those containers, monitor the containers, so and continuously add on the capacity if required. Okay, otherwise your newer containers won't get spawned. So there is a lot of heavy lifting required for the containers, and that for that you have Kubernetes. This is by far the most advanced one from the orchestration. It has been developed on the basis of the Google's own container system and developed by the Google itself, and now it is being managed by the CNCF, that is Cloud Native Computing Foundation. Okay, that is managing the active deployment of the Kubernetes. What Cloud Native Computing Foundation does is it's an organization which is dedicated to the tools which will run in all the clouds. See, what happens is when you start using some one particular cloud, then you can't move to the another cloud. Okay, because of the locking of the tools that on those clouds you start using. Okay, so if you tomorrow start to use AWS, okay, code deploy, then you can't move to Google Compute unless and until you rewrite your code or rewrite your deployment and things like that. Okay, so you will have to but the Cloud Native Computing Foundation is working on the tools. It basically supports the tools which will run in all the cloud platform. It's not causing any locking. Okay, so if you take Kubernetes, you can deploy your own Kubernetes in Amazon or cloud, and then if tomorrow you want to move to Google Compute, you can move your Kubernetes cluster. Kubernetes will not have any dependency if you deploy your own Kubernetes cluster. Now AWS itself has created their own Kubernetes cluster. Okay, so you can run there as well, but you will then have to manage the Kubernetes cluster when you create the Google. Okay, so better is to run your own Kubernetes cluster like that. Okay, then there is Apache Mesos, then there is HashiCorp Atlas, Docker Swarm, AWS Elastic Container Service. So these are all the orchestration services for the containers. Then comes your application deployment, how you can perform the deployment. For that there are tools like Capistrano is there, in which few of the deployments are automatically built in so that you don't have to write. But it's possible to write your own deployments using Ansible. Okay, so any of the deployment strategy out there, if you want to write from the scratch, you can write yourself as well. Okay, then comes your logging services. So there is Logstash, Logly, Logentry, Splunk, Sumo Logic, so which can ship all the logs into your production environment and you can use them and to view. Then there is collaboration and ticketing tools, okay, like Slack, HipChat, Jira, and ServiceNow. So you can use them to collaborate. Slack is just a channel where you can put on the messages to the developers and they can reply back to you. It is having numerous plugins to where you can create the bots and they can automatically reply back. Okay, things like that. All right, so here is how and feedback loop for you, how the things work in a production environment, how the pipeline work. So developers is going to code on their laptop and then going to merge everything inside the SCM using the Git. Then there is a continuous testing that would occur using the Selenium. Okay, and then Jenkins will come into the picture and going to do the deployment using the Puppet or Docker. Okay, Puppet, Docker, or Ansible, so you can use any of the configuration management tool. Okay, you can do the continuous deployment using Ansible or Puppet, and then you can deploy the containers using the Docker. And then you have a Nagios continuous monitoring tool which will monitor this application and provide a feedback to the developers. So this is from what we are covering in the training. Okay, this is exact diagram. Vishal, we are covering Kubernetes orchestration tool. Okay, monitoring tools, Pratik, we are covering Nagios. So this is the exact diagram of what we are covering in our training. Okay, all right, so if you will see, this is our SIM. Okay, so developers are going to commit to that. Then the continuous testing come into picture using Selenium. Then there is continuous deployment. You can, if you are doing the deployment on the EC2 instances, Then you can automate the deployments using Ansible or Puppet or Chef or Salt. And if you are doing the deployments on Docker containers, that's just where it got crashed. So we were here. So you can do the deployments using Ansible or Puppet, and then you can deploy on the containers using the Docker. Okay. And lastly, you can monitor whether you are deploying on configuration management or through on the EC2 instances, or you are deploying on the Docker. Okay, you can monitor through the Nagios, and it will provide a feedback. Okay. So these are all the automation enablers, like your monitoring tool, testing tool. We have already discussed this in quite detail. Okay. And these are the benefits. So you will have faster lead times, frequent releases. Okay. Fewer errors, higher quality of the code, faster recovery. So we have already discussed this part, the issues that the automation supports and solves for you. Bala, it should be available in your LMS portal. The recorded, these trainings are getting recorded, so you will be getting everything inside your LMS portal. Okay. All right. That completes our session. Let's next we are going to cover the virtualization. Okay. So let's take a 5 minutes break. Okay, and then we will be back and we will discuss the virtualization. Okay. Yes, Pratik, these slides will be available to you in your LMS portal. Okay, so let's quickly take a short break and then we will be back, and then we are going to cover with that. I will be on mute during this time. Okay. All right, so everyone back now? Should we start with our next topic of virtualization? Okay, so Rishi says yes. Onkar is back. All right, so let's start with the virtualization now. Okay. All right, so can anyone tell me what's virtualization means? Okay, what is a virtualization? When we talk about virtualization, what exactly is virtualization? Why we need the virtualization? Anyone having any idea? Just try it out, guys. What is virtualization? No one? Servers, Vishal says no physical infrastructure. Okay. And isn't real physical. Okay. Amita says setting multiple virtual servers on same physical server. Okay. And Ramara says utilizing the resources. Yes, that's one of the things you achieve through virtualization. Okay. Abhilasha says we can do the switch overs. Yes, with the virtual machines, it's much easier. Bala says when there is no actual infrastructure to mimic the infra using the virtualization. Okay. Rishi says multiple instances of an operating system. Okay, so some of you are correct, and so see, let's try and understand what is exactly the virtualization and why we really need the virtualization in first place. Okay, for understanding the requirement of virtualization, we will have to go back somewhat in time. Okay, and try and understand how it was done initially and what were the challenges. So initially, when we started to use the servers, there was physical servers. Okay, and we already talked about these were the huge servers like 32 core CPU and 120 GB RAM. Now that's an extremely big server. Okay, and our application might not be needing that much amount of resources. Okay, uh, and then if we have to run number of applications or we divide into the microservices. Okay, and let's say our microservices, each microservice is running 10 servers, and we have 200 microservices like that, then it becomes 2000 servers. So you see how much scale it's like 2000 servers of 32 cores. It's a very huge requirement, right? And you will have to manage a lot of hardware. Okay, and then you really can't control anything from the software because right now we are dependent on the hardware. Okay, now then comes the virtualization. There comes the virtualization, and so what happened was there was these tools known as the software known as hypervisors. Okay, what hypervisors does, it allows us to uh, divide a big virtual machine into smaller virtual machines. Okay, so if we try and you can think of it like, let's say this is our virtual machine. Okay, this is our big virtual machine. So what hypervisors allows is we can partially divide this virtual machine into the four virtual machines. Now instead of one big virtual machines, we are having four smaller virtual machines. Okay, so what it does effectively is that there, let's talk about something. Let's say we were having this virtual machine which was having uh, 12 GB or of RAM. Okay, sorry, uh, and basically let's say it was having 8 core processor. Okay, so we could have divided it into 2 core and uh, 3 GB RAM. Okay, that's much more effective to run our applications. Okay, and instead of one server, now we are having the 4 servers. So you see, it automatically declines the hardware requirements, and it has provided us with much more servers. And depending upon the application utilization, we can create the server. We can divide a one big server into the smaller virtual machines. That reduces our hardware requirements. We are able to run much more machines now, and we are able to scale out as and when required. So virtual machine brought us this advantage that from one big hardware machine, we are able to create smaller machine based on our requirement. Okay, that was the main idea behind the virtualization. Okay, so let's have the deeper understanding on the virtualization. So here is a traditional architecture of how the things was working. Okay, so if we see this architecture, you will see that usually we used to have, this is the physical machine. Okay, that I was talking about. This is basically a physical layer. Okay, and over this physical machine, we are having an operating system installed. This can be anything, your CentOS or your Red Hat, Ubuntu. It can be any of the operating system. And then you were running one big application. Okay, so you see, only one application was being run on each operating system, like on one machine. This is just one machine entirely. It's a one machine, and this is how the systems were created initially. And you see, a lot of resources is being wasted in this traditional architecture. Okay, this was not very much efficient. A lot of resources was being wasted, and this resulted in less value for money. Okay, and you have lesser control on the application and hardware. You can't really do anything behind the course, and you can't, it didn't supported any of the things. So that was the issue with the traditional architecture. Then came the virtual machine. Okay, so now virtual machine brought this advantage with them, that over the same server there was a virtualization layer. Okay, and when we talk about the virtualization layer, it basically allowed us to uh, create these smaller virtual machines. Okay, so instead of running one operating system, we are running 6 operating system now. Okay, and it allowed us to use the hypervisor for that. Okay, hypervisor was the virtualization layer that we are talking about. Okay, and using the hypervisors, we were able to create more number of virtual machines, install operating system on those virtual machines separately. So each virtual machine was isolated with each other, so that one operating system doesn't know about the, doesn't conflict with the other operating system. They all work in isolation with each other, and we are able to install more number of applications on those operating systems. This is what the virtual system brought to us. Okay, and you will see that with each operating system, these there is a isolation between each and every operating system, like that. Okay, and we were able to run more number of applications now. Okay, so newer architecture was much more efficient, much less servers was required in this. Okay, as compared to the previous architecture. Okay, so why do we require the different virtual machines? See, whenever we deploy an application, it has its own dependencies, and each there's two type of dependencies. One is the operating system dependencies, and then there's application dependencies. Some of the application depends upon the operating system dependencies. Like if we talk about the C programming language or C++, then they are actually dependent upon the operating system libraries. So for a C program to work, you should have all the dependencies in your operating system. Okay, then only those programs are going to work. But there are other applications like Java, which comes with their own dependencies. So you will have to download all the dependencies from for the Java, then only you can run the Java program. Both has its own advantages and disadvantages. The advantages come from the fact that if you are already having running the C type of language, it's very much faster than the Java. But the problem comes from managing the dependencies on your operating system, which might conflict and cause the issue. Then with the Java, easily it's easier to ship your programs anywhere. You can run it on Linux, you can run it on Windows, everywhere Java programs look similar to you. Okay, so you can manage those dependencies. Now virtual machines allowed us to isolate both the operating system libraries as well as the application libraries, so we can create multiple applications and run them in isolation on the same server. So we can run 6 applications on the same server without interfering with each other. Okay. Yeah, so versioning that we are referring to is the different operating system, Pratik, uh, which we are referring in this slide. So when we refer to the different operating system, see all these virtual machines that we were creating on the physical system, these can run same operating system or different operating system. So it's possible that we have a combination of RHEL based, Red Hat based systems as well as Debian based systems. We can run any of the virtual machine as we like. Okay, so different versions of different operating system we can create on these operating system. Why? Because they are managing, keeping the dependencies inside their own virtual machine. So each of the virtual machine is isolated from each other, so they won't conflict with each other. Okay, this is what the software like uh, uh, has brought to us for enabling the virtualization. Okay, so this is how it was facilitated that we were able to run the Debian based system as well as the RHEL based system. Okay, so see, when the versioning was introduced, okay, it allowed us to create the multiple environments. We can create the separate environments, like we can create dev environment, we can create prod environments, staging environments, because we were having much more virtual machines now, and we can easily configure the applications on these operating systems, and we can easily configure the different environments, set up the multiple environments. This is how you will see that each of the environments was being set up initially. Now it is a different case, but this is how the things was used to work. Even now it's the same, just that the virtualization that we are referring to is on a hardware which is residing on someone else data center. So it's basically provided to you in the form of an service like on web. So if we talk about the cloud providers, they are also running this same virtualization. They are having the virtualization on the physical servers. The physical servers reside in their own data center. We as a user don't have to manage that data center. That is being managed on our behalf by the cloud providers, and they have deployed their own uh, virtualization layer. So AWS is running their own virtualization layer on the physical servers, and then they are creating the virtual machines on those servers. Whenever we request from a web, they deploy a virtual machine on those physical servers using their own virtualization layer. Okay, and that's how they are able to give us the virtual machine. So whatever machines that we are running, we are able to run the virtual machines. Now virtual machines is having much more advantage than the physical machine. Why? Because you can see it's now virtual, so we can control it from software. Okay, we can code it, we can control it. Previously we used to depend upon the hardware, so we were not having much of the control. So now if we want to increase the memory or we want to increase the RAM, we can do it on our virtual machines. Okay, that's dynamic provisioning is also possible. We can increase the disk space in these virtual machines. So you see, virtual machines brought numerous advantages over the physical machines. Okay, now you will see that the large obviously the large organizations were having this much more complex requirements, where they will have to set up large number of machines and large number of environments to make those works. And then they were having all these patching and everything which has to be done separately. Then the applications were there, so you will have to manage their binaries and dependencies, and then nothing should interfere with each other. Okay, so we were able to manage the infrastructure for the larger organization using these virtual machines. Okay, and virtual machines is not something which is new now. In fact, it is from very early, from 1960s the virtualization was being used, which allowed the multitasking for the program. So programs were able to do the multitasking for that. And you will see that the larger virtualization was introduced by the VMware. This was one of the significant pioneers initially back in the 1998. You will see that they introduced the virtualization for the x86. That is the version that we all use. Like most of the servers are dependent upon the x86 architecture itself. Okay, and that allowed us to partition one big physical machine into the number of smaller virtual machines, and that we can run the production environment. Okay, and you can easily create different environments. You can simply copy one virtual machine to another virtual machine. You can even take a snapshot in the VMware and then go to some other VMware setup on some other virtual machine and then easily create those virtual machines. So you see, it allowed us, see, it's not possible in the physical infrastructure. If I say to you that go ahead and create the exactly the same server to somewhere else, then you can't copy the exactly create something out of it, right? Because it's physical now. But when we came down to the software, okay, the virtualization layer, then it was possible to take a snapshot and restore that snapshot to create a new machine, so that it would exactly be in the same state as the previous machine from which the snapshot was taken. Okay, so uh, this was also facilitated the more servers to be built up. Okay, and uh, so you don't have to boot large number of servers. Instead, you can easily create the virtual machines out of it. Okay, now virtualization software is itself known as hypervisor that we referred to initially. Okay, hypervisor is the one which is responsible for creating of the virtual machines. Okay, and now there are two types of virtual machines which is supported. So one is type 1 virtualization and another one is type 2 virtualization. Okay, so we are going to understand both of the virtualization layers and how they work. Okay, let's talk about the type 1 virtualization. If we talk about a type 1 virtualization layer, okay, you will see that this is the physical layer of, sorry, let me take a pen. So this is the, okay, this is your hardware. Okay, and this is your physical machine. Basically it's the server or the physical machine on which we are going to create, and this is having huge capacity. Okay, and now we have to divide this. Now we are directly going to install the hypervisor over this over the physical server. Okay, so you will see the hypervisors are directly installed over the hardware and there is no operating system directly installed. So you install hypervisors over hardware. What is hypervisor? Hypervisor is a customized, okay, this is customized OS. So it has been designed by like VMware to run the virtual machine. So it's entirely customized operating system which facilitates. And why we install directly? Because it has lower utilization. See, it uses less resources of the hardware, so more resources are available to provision your virtual machines. Okay, now this is one virtual machine, this is one virtual machine. Okay, and this is another virtual machine, like that. Okay, So here we are taking two virtual machines right now. So if we talk about this, you will see that uh, once the hypervisor was installed, we can divide the server. See, you can take the CPU resources, RAM, and the disk, and then you can effectively divide according to your requirement. So all the resources of the physical servers is divided in between various virtual machines. Okay, and that allowed us to create the different virtual machines. Now this is type of virtualization where we are directly installing hypervisor over the hardware. This is known as type 1 hypervisor, okay, or type 1 virtualization layer. Okay, so anyone having any questions in this? Yes, Sridhar has a question. This hardware component that you are referring to data center. Yes, so Sridhar, within the data center we will be having a physical server. Okay, that is where we are referring this hardware to, that physical server, okay, which is having 32 core and 120 GB disk. We are referring to that. That is the physical server which resides in our data center, and we have directly installed hypervisor over it, and this hypervisor allows us to create the virtual machines over this hypervisor. Okay, we can directly create over virtual machines over this hypervisor. Okay, anyone else having any other question regarding the type 1 hypervisor? See, if you install hypervisor directly over the physical machine, then it is called type 1 hypervisor. Now, if we talk about the type 2 hypervisor, okay, in this you will see that we install an host operating system. So you are going to install an operating system first. It can be your Windows operating system, Mac operating system, or your Linux operating system. We just need one operating system to be installed over the hardware, and then on that operating system now we are going to install the hypervisor. Okay, so you will see that the okay, so you will see that the host and the hypervisor, okay, hypervisor is installed on the host operating machine itself. Okay, this is the type 2 hypervisor we are talking about. So you are having a base operating system running your Linux, Mac, or Windows, and then you install the hypervisor over it, and over that hypervisor you are going to install different operating systems. Okay, and you can create a virtual machine over that hypervisor and then install the operating system and run your application over that. Now what is the advantage of this? See, if you look down closely to these virtual machines, so you will see that uh, type 1 hypervisor is more suitable for the organizations which are running their own data centers. So they are having this huge physical machines on which they can directly install the hypervisors, and then some team can provision the virtual machines over it. Okay, this is how the companies use the virtualization, that is called type 1 hypervisor. Now it's if you consider yourself as a personal user, okay, so you are right now having a hardware, that is your laptop, okay, and you are having a Windows operating system installed on it. So that's the host component as an end user. Okay, so now what you can do is you can install the hypervisor on your laptop. Okay, although you are running a Windows, you can install the hypervisor which is available for your operating system, that is Windows. Once you have installed the hypervisor, you can install any operating system over it. So you can install Linux, you can install Windows, you can install Mac. So you can install anything over that hypervisor. Okay, and then create the virtual machines. So for our labs, we are using the type 2 hypervisor. We are going to use this architecture. Okay, you are already having the hardware and operating system installed. We are going to install an hypervisor, that is Oracle VirtualBox. Okay, once you have installed the Oracle VirtualBox, then you can create any number of virtual machines over it. Okay, and for that we are using the Vagrant. So everyone understands the type 2 hypervisor and the requirement for the type 2 hypervisor? Anyone having any questions? All right, so what are the examples of the two? See, if we talk about the type 1 hypervisor, there is Oracle VMware ESXi server is there, okay? And there are other like VMware ESXi is there, Microsoft Hyper-V is there, Citrix Zen server is there, Oracle VM server is there. So these are the type 1 hypervisors which you can directly install on your physical servers and then create the machine over it. If we talk about the type 2 hypervisors, then there is VMware Player, VMware Workstation, and Oracle VirtualBox. In our case, we are using Oracle VirtualBox, okay, for creating the virtual machines. Yes, Vishal. In type 1 hypervisor, we don't need operating system installed on the main physical machine. Okay. We can directly install the hypervisor. Okay. Hypervisor is nothing. It's a basically a customized operating system. So it won't run your Linux command, things like that. It is limited down. Everything has been removed and it is limited down to run only the virtual machine. So you can now only create the virtual machines over your physical VM. You can't do anything else. Okay. Yes, Subrata. So AWS uses type 1 hypervisors because they are working on the physical servers, right? For them, not to the end user, for AWS only. Okay. They are using the type 1 hypervisors. They work at this hypervisor layer to modify those hypervisor and enhance the performance of their virtual machines. And the end user, that is you, when you work on AWS, you only create the virtual machine. Okay, they allow you to create the virtual machine. All right, so let's move ahead. So now you will see that if we talk about the CPU virtualization, okay, so most of the modern hardware virtualization platforms allows you to do the CPU virtualization as well, okay, and you will by default it is disabled in the BIOS, okay, but if you understand what you are doing, then you can enable the CPU virtualization in your BIOS, okay, and once you enable it, it will also limit down the CPU utilization. See, the thing is with the CPU is that CPU is available as a whole, right? Although other things can be isolated, CPU is little more complex, and if you divide the CPU, then by default it's like if you even create the virtual machine, your machine can use as much CPU which is available, so other virtual machines performance is going to degrade. But now you can enable it in the BIOS, and then your CPU will also be divided across those virtual machines which you have mentioned, and then it will only provide you that much performance only from the CPU cycles, okay. And so you can use KVM or FreeBSD based kernel modules to enable the CPU virtualization. They can effectively do the virtualization for your CPU as well, and so it can convert your host operating system into the type 1 hypervisors. So if you are using the KVM, let's say if you are using KVM and all, then we can convert the type 2 hypervisors into type 1 hypervisors as well, if we want to do like that. So it's also possible with the KVM. These are the advanced hypervisors through which we can achieve this, okay. See, it's altogether a different configuration. See, Pratik is having a question. Is there any difference in configuration of type 1 and type 2? Yes, there is a whole lot of configuration difference. See, in type 2, we are already having an operating system installed, right? So we can directly install the .exe. But Type 1 virtualization comes in the form of an image file which you install just like an operating system on the bare metal. Okay, so there is a huge difference. And type 2, you can run any of the commands and things like that, even use the physical servers directly like you are using your laptop or by running the operating system. But in case of type 1, it's not possible. You have to create a virtual machine, then only you can do anything on it. It's just facilitating you to create the virtual machine, nothing else. You can't open any browser, you can't do anything else. Okay. Yes, Pratik. So over in the organizations, you are going to run type 1 hypervisors. Okay, usually the data center teams were responsible for that. But as over here, like you can use the type 2 hypervisors. Why? Because you don't want to like affect your initial running laptop. You can use the type 1 hypervisors as well. Okay, but in that case, you will have to format your laptop and you will lost all that data, and then you will have to create virtual machines over your laptop. No one wants to do that, right? All right, so here are the important virtualization products. So you can use VMware vCenter, vRely Suite, Microsoft System Center, Citrix System Zen Center. Then there is VM Turbo, Dell Foglight, Embotex, SolarWinds, Splunk, and IP Switch. So these are all the different virtualization products that you can use. Okay. All right, that completes the virtualization for us. Now we are aware what is type 1 virtualization, where to use type 1 virtualization, where to use type 2 virtualization. In our next session, okay, we are going to cover the Vagrant initially and then the Vagrant lab. Okay, now Vagrant is utmost important. It will take about an hour to complete. Okay, so the Vagrant is the tool which we are going to use to create all the virtual machines for our labs. Okay, so we are going to use type 2 virtualization and then create virtual machines using the Vagrant. Okay, just with a single command you will be able to create a virtual machine, and it will be free, so you don't have to worry about any credit card usage, any of the billing and things like that. You will run the virtual machine directly on your laptop without affecting anything on your laptop. Okay, so nothing will get affected, and you can effectively use your laptop more efficiently for running the virtual machines. Vagrant is commonly used for creating the dev environments. Even you will see that lot many even when you work in an organization, you will use the Vagrant to create local machines, run Ansible test, Ansible configuration and things like that. So it's commonly used for that, and you can just provision it with one command, that is Vagrant up. You just run that and everything machine will come up to you. Okay, you don't have to do anything else, just one command and your machine will come up. That's the kind of automation we are talking about. So we are going to use the Vagrant to provision our virtual machines. Once you understand this process, how the virtual machines are being created, then going ahead, I will let you know what are the configurations which is required for creating the virtual machines. Okay, and then you can easily create it. If you want, I can cover the Vagrant right now. Okay, or we can cover it later. So let me know if you want to cover it now. We are not having much of the time left right now. Okay, so we can take this next time. It's a small topic, so let's take this next time. Okay, Vagrant, we might have to leave in between, so it's better we take next time. Okay, so next week we are going to cover the Vagrant, and then we are going to perform the lab for the Vagrant as well. All right, thanks everyone. That's all for the today's session. See you all next week. And you will get access to all the videos, all the slides, everything in your LMS portal. If you are having some issues, you can reach out to the Cognitia support. Just drop them an email. They will make everything available to you. Okay. All right. Thanks everyone. Ending the session now. Abhilash, you don't need any other software. You can download the latest VMware or the latest VirtualBox and the Vagrant softwares from their website. I will share you the link, okay, in the next session. But till we are going to discuss, you can put them on download, so that once we cover the theory part, it will already be downloaded. Okay, you don't need anything extra. All right, ending the session now. Uh, Kanan is having a question. Could you let us know which Linux are we using, Ubuntu or CentOS? We are going to perform all our labs on the CentOS based operating system. Okay, so we are going to use CentOS Linux, CentOS 7.5 to be exact. I will let you know how you can use it, so don't worry about that. Omkar, I am going to provide you the URLs when we are going to do the lab next week. Okay, don't worry about the URLs. I will provide you everything. Okay, so Pratik is asking for the type 2 hypervisor. See, Pratik, you are never going to work on the type 1 hypervisors. Okay, why? Because in an organization, that's a work of the data center team. Okay, so you will, as in DevOps, you will never work on the type 1 hypervisors. I can tell you that. Okay, so don't worry. I already told you, DevOps is not about creating the virtual machines. Okay, this is something out of the scope of the DevOps. So we are not going to focus on how we can get the virtual machines. See, cloud is something which you could be interested in, but type 1 hypervisors, you will never work in a data center like that. Okay. And this is like out of scope for the DevOps. Yes, Kunal, so we are going to install on the Windows operating system only. Okay, I will be using the Windows, not this Mac one. Okay. I will show you all the labs on the Windows operating system only, so everyone can replicate. Okay. Yeah, you can see all the people who are having Mac or Linux. It's completely fine. You can use Mac and Linux. Even like I will tell you, it's easier to run on Mac and Linux. It's difficult to run on Windows because you will have to use an additional software like Putty to get the terminal, while Mac and Linux already have the terminals built into them, and less number of steps are required in that. Okay, Vagrant and VirtualBox both are available for all the operating systems. You can run on Mac, Windows, Linux, anywhere. Okay. Yes, Nupur, you are going to install the software before next class. Okay, so not before the next class, during the next class. Okay, so before we start on the Vagrant, I will provide you the links. You can download it and put it on install. I will show you everything. Don't worry. Okay. Next will be our hands-on lab session. Okay, so we are going to perform the hands-on lab in next session. All right, any other questions, guys? Because I was just going to click on the end training. If anyone is having any question, do let me know. Otherwise, I'm going to end the session now. And don't worry, I will show you each and every step. So everything we are going to work. Okay. See, if you want to download, if you want a link to download, let me share you the link to download. Okay. So VirtualBox is a software which has been created by the Oracle Corporation. So you can visit this virtualbox.org site. Okay, and here you can go into the downloads. Here you can select your operating system. Okay, virtual 6.0.4 is there, so you can download the VirtualBox 6.0.4. Okay, so here is the link for downloading the VirtualBox, and similarly you can download the Vagrant. So Vagrant is provided from the vagrantup.com. Okay, and you can select your 64-bit Windows operating system if you are having a RAM more than 4 GB. Okay, and just install for your operating system. So these are the two binaries that we require for installation. Okay, you can use this link. Okay, so you can keep the downloads on your system. Just download it and keep it on your system. Okay, otherwise I will share you the links again, don't worry about that. Okay, all right everyone, that's all for the today's session. I'm going to end the session now and see you all in next session. We are going to perform step by step, so don't worry, we are going everyone can perform the lab along with me. Okay, and you will also have a recording, so you can even perform later, no, if you don't want to perform at that time or having some issue. All right, thanks everyone, ending the session now.